All right, in example one, we went over a very simple, just find the quadratic regression. Now here's our application problem. It says, partially because the Americans are living longer, the number with Alzheimer's disease and other dementia is projected to grow each year. The table below gives the millions of US citizens with Alzheimer's from 2000 and projected to 2050. So the first thing we need to do is create a scatter plot of the data with X equal to the number of years after 2000 and with Y equal to the number of millions of Americans with Alzheimer's disease or other dementia. So if you were, okay, let's go with this first. My X is equal to the number of years after 2000. So this means this is my X right up here. And so if it's after 2000, we're 0 years after 2000 and 2000. Then we are 10 years after 2000, 20 years, 30, 40, and 50. You do want to be careful. Just because these first 2 or 3 went by tens doesn't mean all of them go by tens. You need to make sure, but these are all increasing by tens. And then my Y is the number of millions of Americans with Alzheimer's disease. So this is 4 million, 4.9 million, 6.8 million, and so on. So if you were creating a scatter plot by hand, all you were doing is plotting points. You would plot 0, 4, 10, 4.9, 20, 6.8, and so on. But we'll make this in our graph. If you need to do it on paper, just plot the points. That's not anything to do with your calculator. Okay, so here are my instructions for creating a scatter plot from the previous page. So the first thing we want to do is go to Stat, which is right here. I'm going to go ahead and hit enter because it's already on edit, which is where I want it to be. If we need to clear list, we're going to arrow up to highlight the list, press clear and then enter. So I'm going to arrow up to list 2. I'm going to hit clear, which doesn't erase anything. And then you have to put enter. I'm over here, do the same to list 1, clear, enter. Now I can put all of my lists or my numbers in. My X is my L1. And my millions is my Y by L2. Okay, I cannot emphasize this enough, and it needs to be honestly part of the instructions. Check it. It takes 5 seconds to check these numbers, but if you get something wrong, it's going to mess up everything. So take the 5 seconds to check these. So 0, 10, 20, 30, 40, 50, check. 4, 5.9, 6.8, 8.7, 11.8, 14.3. So I like mine. Once I have all of those in there and I like it, now we need to go to Y equals. I need to clear off anything that we have. So I'm going to clear this and turn my plot 1 on. So it's blinking. Let's turn that on. And so when you get off of it, it should be solid. And then I'm going to go zoom 9. So here is my scatter plot. So now let's find the quadratic model that models this data, and we are going to report this model with 4 significant digits. Okay, again, if you need to go over significant digits, you need to watch your lecture over significant digits. Okay, so let's go here and follow our steps for a quadratic regression. We're going stat. Now I need to come over here to calc. And because it has asked to find the quadratic model, I need to come down here to number 5. So either arrow down, and hit enter, or just hit number 5 on your keypad. We're going to go past all of this. I'm going to skip all this optional. If you want to see what that optional stuff does, go back to linear regressions in module 1. So I'm just going to hit calculate. So here is my quadratic regression. So we have y equals ax squared plus bx plus c as my basic formula, and here's my a, b, and c. So for my a, these first 2 zeros do not count as significant digits. So this 2 is my first, second, third, fourth significant digit. That 1 makes that 7 stay. So this is 0.002107. That's my a. So it's a times x squared. That's what makes it a quadratic, is that x squared component. My b is 0.0. That 0 does not count. My first significant digit is that 9. So we have first, second, third, fourth significant digit. That 5 is going to make that 8 round up. So we have plus 0.09779x. And then my c, that 4 is my first significant digit. We have 1, 2, 3, 4. That 1 will make that 7 stay. There is my quadratic model. Now, part C wants to know, graph the data in the model on the same axis and comment on its fit. Well, I can comment on its fit without really needing to graph it because of this r squared. My r squared, let me come over here. R squared is about let's go 9926. Okay, and remember, however close r is to 1 or -1, the better fit it is. 0.9926, that is really close to 1. So this is a very good fit. And so I am going to say good fit. And when you come to this problem in my math lab, you will too. You're going to have a good fit, an excellent fit, a decent fit, or no fit, something like that. I don't know what makes good from an excellent fit. I don't know if it's excellent or a perfect fit. One of them is maybe even perfect fit. Maybe it has to be exactly 1. I'm not sure, but when you get into my math lab, just hit good fit. Now, if we wanted to actually model this, we could. If I type this in, which I'm going to need for D and E, so that's really the only reason I'm doing this part. And I graph that. You can see it's hitting those data points pretty well or barely missing them. These are all, I mean, that's kind of the worst miss right there, but these are still touching. So that's a pretty good representation of that data right there. Now for part D, wants to know how many Americans does the model predict will have Alzheimer's disease or other dementia in 2056? So again, if my X is equal to the number of years after 2000, this right here means that my X equals 56. So we've already graphed it. I now need to do trace 56, enter to get my answer. So I am going to turn my plot 1 off just so I don't see those data points. So this is now just my regression. And now I'm going to do trace 56. Okay, so we get an invalid error, and this is going to happen a lot when it comes to these regressions. When you get that, the first thing you always want to check is your window. Weirdly enough, my window stops at 55 and I'm wanting to know what happens the next time at 56. So let's just come down here. I'm going to go to 65. 60 would work. 70 works. Just go somewhere past what we're trying to do here. Let's hit enter. And now if I do trace 56, enter, we get 16. Does it tell me how to round here? No. Let's just go 16 point. Whatever. I'll write them all. My math app will tell you how to round. I'm just going to round them all. Okay, because these are talking about millions, this is 16,290,792 people. But this is in millions, so 16.290792 millions. Okay, and our last one here. In what year, so that tells me right here, I'm solving for X. In what year after 2000 does the model predict that 10.2 million Americans will have Alzheimer's or other dementia? We are going to round up to the nearest year. So now that represents my Y. So in my Y2, I'm going to put 10.2. We will graph it. Hopefully I see an intersection, and then we will find the intersection. Now I can tell you kind of where this is going to happen. If I'm looking for 10.2, I know it needs to probably happen somewhere in between 2030 and 2040. Hopefully our answer will match that. So, and for Y2, we'll put 10.2. Let's hit graph, and we have an intersection. So to find the intersection, we need to go up here to calc. So second trace, number 5. So either arrow down and hit enter, or just hit number 5 on your keypad. And then enter, enter, enter through first curve, second curve, and guess. And here is my number here. We get X is about 34.956. Okay, telling you right here. And so if we are rounding up, that is 35. If we're rounding, that's 35. So 2000 plus 35 tells me in 2035, which is exactly what we said, that it should be in between 2030 and 2040. Happens to be right in the middle. Now I do want to talk about this round up. Even if this said, let me do this in a different color because this is a side note. And here's the stickies. Even if this number was not 34.9, well, let's pretend that my X was about 34.0, I don't know, 2. 34.02. This is really, really close to 34, right? It's just 0.2 above 34. But because my instructions say round up to the nearest year, this right here would still round to 35. So when they say round up, no matter what this decimal is, this whole number needs to be the next one up. So in case your answer is something close to this, you need to make sure you still round up if it tells you to round up to that nearest year.